Today's notes are on nth roots and rational exponents. Please try the warm-up on your own and then scroll down to look at the notation. Your rational exponent notation is in the form of a raised to the power of m over n. If you change this to radical notation, the top of your fraction, the numerator, stays with the base, either underneath or outside the radical, and the denominator of your fraction tells you what power of root you're taking. Same goes for a negative, but if it's a negative, remember that we move it to be underneath 1 to flip the fraction. For real nth roots, you can let n be an integer greater than 1 and let a be a real number. If n is odd, then a has one real nth root. If n is even and your a value is greater than 0, there will be two real nth roots. If n is even and a is equal to 0, then there will be one nth root. And if n is even and a is less than 0, then a will have no real nth roots. Let's look at the first example. It tells us to find. For part A, n is odd, which tells us that we know that there's going to be one real nth root. And we're going to look at simplifying this. So we either want to put it in our radical notation or our rational exponent notation. And there's no m value, so we're just going to use 1. So if I looked at this in radical notation, this would look like the fifth root of negative 32. Or we could write this as negative 32 raised to a power of 1/5. And if we use our calculator to help us simplify, we get an answer of negative 2. Same thing for B, we see that n is odd, which means that there's going to be one real nth root. And if we set this up here in radical notation, we're going to have the cubed root of 64. Or we can look at this as 64 to a power of 1/3. Either way, when you plug it into your calculator, we get an answer of 4. Please try and do example C and D on your own. Next, we're looking at rewriting the expression using rational exponent notation. So we're going to take it from its radical form, so let's rewrite that so we don't have to flip back and forth. So that was the nth root of a to the nth power. We're going to rewrite that so it's a to the power of m over n. So in this case, my base is 13, that's my a value. Because you don't see an exponent attached to the 13, we know it's a 1. So this is 1 over the n value, which is 5. And I said the a value was 13, so 13 to the power of 1 over 5. For example B, again, my m value is 1. This is 1 over 7 to the power of 1/3. And then because I want to get rid of the fraction, I could say that this is equal to 7 raised to the power of negative 1/3. Please try example C and D on your own, we're going to look at example 3a, going the opposite direction, writing this using radical notation. So the denominator tells me what root I'm taking, so I'm taking the fourth root, and my base goes underneath, and it has a base of 7, and the m value is 1. You don't need to write the 1, but this is where it would go. For example B, we're going to start by getting rid of the negative by moving this whole term to the denominator and turning it into a positive exponent. Then we will rewrite it using radical notation. So this is the fifth root of 4 squared, or you can write it as the fifth root of 4 where this entire thing is squared. You can write it in either form. And once again, I'm going to have you try example C and D for this on your own, and we're going to look at example 4. Example 4 asks us to evaluate the expression without using a calculator. So first, it might be easier for you to look at it in the other form. So for the first one, I'm going to change this to be radical notation. So that's the square root of 16 raised to the power of 5. And it's easier for us to look at it like this because we know that the square root of 16 is a positive or negative 4. And for these problems, we're going to use a positive 4. So this becomes 4 to the 5th power. And this would be a little bit tedious to calculate by hand, 4 times 4 times 4 times 4 5 times, but it would be possible, and it would get you an answer of 1024. Let's make a little note up here. When asked to evaluate, we're going to use the positive answer. So again, the square root of 16 could have been a positive or a negative 4, and we're going to be using the positive answer, so we used a positive 4. Alright, there are two ways for you to think about part B. The first would be if you knew that the fourth root of 16 was 2. We could rewrite this as 2 squared, which gives us our answer of 4. Or the other option for this one, if you didn't know that without a calculator, would be to write this in exponent notation. We get 16 to the power of 2 over 4, which we can simplify to 16 to the power of 1/2, because 2 and 4 both have a factor of 2, which then, if we rewrite in radical notation, we know the square root is 16, and we know that that is 4. See if you can do example C and D on your own before looking at example 5. Example 5 is the opposite of example 4 and asks us to use a calculator in order to evaluate. So in order to do this, first we need to figure out how to enter a fifth root into our calculator. So first you're going to put the number, so in this case we would type in a 5. Then on the graphing calculators, you're going to hit the math button. And you're going to scroll down to option number 5, which looks like a little x with a radical. Then we'll hit enter again. This will give you the radical, and you'll have to enter your second number here. So this would be your a value. The first numbers that we're using is our n value. You can use the same thing on little scientific calculators, you're looking for this symbol, so you'll type the N value in first, then select this symbol, type in your A value, hit enter, and it'll give you your answer. So to check, try it on your calculator. You should get -7 for A. And then for B, you should get, it says round to the nearest hundreds place, so you should get 539.87. Try examples C and D on your own if you're getting different answers for A and B. We will go over in class one more time how to use the calculators to enter roots other than the square root or the cubed root. Looking at our last example, example number 6, it's asking us to solve each equation and again, round to the hundreds place when appropriate. So your first step is going to be to isolate the variable for every single one of these. Alright, so for us, I want to get x to the 4th by itself, so I'm going to divide everything by 6. So we get x to the 4th is equal to 625. And if I want to get x by itself, because this is x to the 4th power, I need to take the 4th root of both sides. Using our calculator, the 4th root gives 625 gives us an answer of 5. And because it's asking us to solve versus evaluate, we can use both the positive and the negative answer. So anytime you have an even root, make sure that you include the plus or minus. So an even n value, include the plus or minus. Alright, next we're going to look at example B. Your variable term is already isolated because it's inside the parentheses, so we can start right away by taking the cubed root of both sides. I'm taking the cubed root because it's raised to a power of 3. So when I take the cubed root, I get x plus 1 is equal to the cubed root of 18. Because we're taking an odd root, and I'm taking the odd root of a positive number, we're going to only use the positive version of this. So if I subtract the 1 over, we get -1 plus the cube root of 18. And then we can use our calculator to help us. This gives us x equal to 1.62. So let's make a little side note off to the side. You must only use the positive number because you are taking the cube root of a positive number. And this is true because multiplying a number by itself 3 times, if I want to end with a positive number, I need to start with a positive number. A negative times a negative times a negative is going to give me a negative answer, and the 18 is positive. So that's how we know we're using the positive x value. Please try and do example C and D on your own. C is similar to A, and D is going to be similar to B. We will talk about the rest of the examples together tomorrow in class.